because I want to settle the lab, okay, which you should learn in class first. Then later we will do the lab this afternoon. Okay, that's why I skip. Okay, so mostly dia tak ada, it doesn't have any relation. Maksudnya when we study lecture 8, it's quite distinct from lecture 6 and 7. Okay. Okay, so can we start now our lecture? Okay, I hope you can focus because this is a very important topics, okay, which we will go to did I say share screen? We will go to the chemical aspect of the soil. Okay. Okay, boleh nampak skrin saya Iklima?
Boleh.
Okay. Okay. Okay, so the objective of this lecture, as in today, okay, this morning, I hope at the end of the lecture, you will understand about the properties of soil colloid. You will understand what actually is the soil, what made the soil. Apa bahan binaan soil tu. Okay, so that's why we call it as a colloids. Okay, so we have different types of clay. Okay, so what differentiate between clays? Okay, so okay, so the most important that you have to concentrate and understand is about the CEC. What is cations, what is an ion, and what is the CEC. And also you have to understand the calculations of the CEC. Okay, as I generally I have mentioned to you, you dah tahu kan CEC tu apa? As if that soil it has their own hand. For example, I am a soil, I have two hands, meaning that I can hold two nutrients. Okay, one is calcium, one is magnesium. Okay, another one I have for example my son, okay, dia ada he has four hand, for example lah. Okay, so 4 hands, then he can hold 4 nutrients. Okay, so we want to actually determine how much of nutrients in term of calculations and units. Maksudnya ada berapa, ada 4 ke, if you have 4 ppm or 4 ppm of CEC, 2 ppm of CEC. Okay, quantitatively you should know. Okay, because last time in principal plant science you only learn about what is CEC, what is the general properties of CEC. But in this lecture we will go into details, more to calculations. Okay. Okay, so what is soil colloid? Okay, so the soil colloid is the most important parts of the soil. As you know that soil is it has 3 different sizes, which are sand, silt, and clay. But the most productive or the most important size of the soil is the one which is the smallest particle, which is what we call as colloids. Okay, so what is colloids? Okay, colloids should include the clay and also the organic matter. Okay, so when we talk about colloids, there are a few questions. Okay, before we talk about soil colloids. Okay, so actually when you put fertilizer into the soils, which part of the soils hold the nutrients? Okay, is it the nutrients is macam terapung-rapung, it just floating inside the soil, or it is hold by the soil? Okay, that's the questions. Okay, how it is hold, how much it can hold, because as I mentioned to you, sand is not good. Okay, not sand is good. No, sand is not fertile because it cannot hold nutrients. What does it mean by hold? Hold meaning that in terms of the properties of the soils, the CEC properties. Okay, that's why how much the nutrient can hold. In this lecture, we will understand. Okay, how to restore productive after logging at rainforest of oxysoil. As I mentioned before, when you do mining activities, why before the mining activities, the grass is there, but after the mining activities, it takes like 10 years for the grass to grow. Okay, meaning that the soil is not fertile. Why? How to restore the productivity, how to maintain the productivity. Okay, so how contaminated nuclear power plant waste contam food grown on downwind soil but not others. Okay, for examples, why there is heavy metals in the soil. Kenapa heavy metals ni ada dalam soil? Okay, so there are some questions that are actually answered by the existence of the colloids, by the existence of these small particles, because it has hand, it can hold those things. It can hold either nutrients, which is good for the plant, and also it can hold the heavy metals, okay, which is harm to the plant, harm to the environment. It gave harmful effect. Okay. Okay, so what is soil colloid? Okay, soil colloids are the most active portions. Okay, meaning the most fertile that makes the soil alive. Okay, that make the soil can sustain life. Okay, so it's most active portions of the soils and largely determined by the physicals and properties of the soils, meaning that from its characteristic, it has a very small particle. It is a small particles which should have a surface area, a large surface area. It has good surface charges. It can absorb cations and anions. Okay, so cations are the positively charged ions. For examples, we have calcium, magnesium, potassium, and also it can hold anions. And ions are although soil can hold um, a major amount of cations, but soil also have a capacity to hold anions. So what is some examples of anions? Siapa ni? Nurin. Contoh anion. Nurin.
Ya, doktor.
Apa soalan saya?
Anion kan, doktor?
Give one example of an ion. Nurin, an ion, Nurin. Okay, Sarah Hani. Give me one examples of an ion.
Sulfate.
Betul? Okay. Anisu, can you give me one examples of an ion?
Oxygen.
Huh?
Oxygen.
Oxygen, no. It should be a nutrient. Okay. One no Nasrin. Give me one examples of an ion.
Phosphate.
Pandai. Okay. Ifahanan. Ifahana.
Nitrate.
Okay, very good. Okay, so that is an ion, meaning that soil can also hold an ion. Okay, so that is the answer of colloids. What is actually colloid? Dia sepatutnya a small sizes of particles. It has large surface area. It has good surface charges, and it can absorb cations and anions. That is the characterizations of what is soil colloids. Okay, so basically soil colloids, it reflects the most simplest thing that you know is clay. Okay, so the structure should be like clay lah. Okay, but not only it restrict to clay, but organic matter also is categorized as a soil colloid. Okay, it has a large surface area. Okay, for example, okay, these are some types of clay. Kalau you nampak, please when I give lecture, please pay attention. Okay, because this is kaolinite. Okay, if you see, it's like flaky, kan? Okay, this is kaolinite is a type of clay. Okay, so number 2, this is montmorillonite. If you see that the structure is quite different. Okay, so when the structure is different, it gives different characteristic. Okay, so later we will understand different types of clay which has different characteristics of water and nutrients holding capacity. Okay, you see dia macam flaky macam ni, tapi this one the shape is like this. Okay, so this is the real picture of a clay. Okay, that's why we call it as, although it is very small particle, but it has a large surface area. Okay, because of the structure of the clay it's like a layers. Okay, so this is another example. Kita ada kaolinite tadi, we have chloride, we have smectite or elite. Okay, so this is elite. You see the size is the shape are different. Okay, meaning that the capacity of it to hold water and also nutrient are actually different. But this is just a visualization ataupun yang what you can see. But in terms of the chemical properties, that is because of the structure, the structure that we will learn later. Okay, so surface charges is very important. It's greatly influence the soil chemicals and physical behavior. Okay, so actually soil colloids, when we talk about clay, it should carry negative and also the positive charges. Okay, so how many it can hold, that depends on the type of clay, as I mentioned before. Okay, most of the organic and inorganic soil colloids carry a negative charge. However, that's the reason why anion ataupun like all of you answered just now, for example, nitrate, phosphate is prone to leaching. What is leaching? Leaching is actually the loss of these nutrients from the soil environment, meaning that it can be easily washed away from the soil profile. Okay, so the question here which you have to think is that how we should maintain this nutrient. Okay, as you know, nitrate, nitrogen, phosphate, phosphorus is macronutrients, meaning that it is needed by the plants or crop in a large amount, but it is easily washed away. That's some challenges in agriculture. Okay, so then we have what we call as acid soil should have positive charges more than negative charges. Okay, amount of surface charges is depends on types of soil colloid. Okay, which I said just now, different types of clay influence the soil chemical conditions. Okay, that is because of the structure. Okay, structure to susunan. Okay, the arrangements of the structure in clay, which we will go later. The structure layers determines the surface charges. That's why I said that. For example, kaolinite. Kaolinite is not good in exchanging nutrient. Nutrient is all, it has to be easily hold and easily released. Okay, for example, kaolinite, it can trap nutrients, but it cannot release the nutrient well to the plant. Meaning that it holds and it hold it tightly. So a good type of soil, a good type of clay, a good type of colloids it is exchangeable. The nutrients or the cations or the anions are exchangeable. That's why we call cation exchange capacity. The capacity of the soil to exchange cation. It's not that the soil can hold cations for itself. Tak. That's why in soil ataupun in agriculture, in crops, in cropping system, we call it as available nutrients. Because some nutrients, they are hold tightly by the soil, so it's not good. It have to release, the soil have to release the nutrients when it is required, okay, by the plant. Okay, so okay, So basically a soil yang ni kenapa dekat sini? Okay, this is just for overview, okay, which later we will learn about this later. Okay, when we talk about acidic or alkaline soil, that is because which charge does it hold more? Okay, for examples, pH acidic caused by H bound on the salt, that is because if you see here, okay, the soil are holding more anion, meaning that it carries the acid properties. Okay, if we compare with the soil with pH 8, okay, which is slightly alkaline, okay, so if you see here, the soils are holding more positive cation. Okay, but it doesn't have H plus, because H plus characterized by the acidic conditions, and acidic conditions characterized by H plus. Okay, so that's why this is acidic conditions and this is alkaline conditions. Okay, that is meaning that the balance of the soil. Okay. Okay, so absorptions of cations, okay, as soil colloid poses negative charges, okay, when we talk about soil colloids, it has more negative charges in its surface area. Okay, so when it has negative charges, dia macam it likes a battery. It can hold or it can attract the positive charge. Okay, positive charge is the cation lah. Okay, for examples, the cations are aluminium, calcium, magnesium, potassium, H plus. If you see here, this is H plus. Okay, H plus is very easily attracted by the soil colloid. Okay, sebab apa? Sebab dia ada high affinity. Dalam banyak-banyak ni, okay, yang paling senang be attracted are H plus. But H plus is actually, it carries the acid properties. So it's not good. Okay, so when H plus is a lot in your soil environment, it is easily attracted at the clay particle. While acidic soil is not good. Faham Nurin? Nurin. Ni siapa ni? Sharifah Abarina, faham? Sharifah Inshira.
Faham.
Sarahani.
Faham.
Nur Husna. Husna jarang panggil nama.
Faham.
Syairin. Faham? Tak adalah tu. Alia.
Faham, Doktor.
Nisrina.
Faham.
Hafizan.
Boleh, Doktor.
Boleh. Izzah.
Faham.
Farisha.
Faham, Doktor.
Azuri.
Faham.
Aniso, I don't have to call you because I know Aniso. Usually when I call her, she will pay attention. Okay, so that's the reason of that's the answer of why some soil we call it as acidic soil. Okay, which later H plus ni kita akan study on that later. Okay, but I just explain why I'm teaching. Okay, so that is all cations. Okay, meaning that it is easily attracted by the clay particles because clay particles have negative charge. It's like a battery, or I assume that the soil has hand. Okay, so your hand is negative and it holds all the cations. Okay, so actually when a moist soils, okay, cation exists in hydrated state. That's why you have to water your plant, because when you water your plant, the cations is in hydrated state, meaning that it is surrounded by the water. So it can vibrate about in a swarm near the colloidal surface. Dia macam it's like a magnet. Okay, when it has a electrostatic attractions to colloidal surface, so that the individual cations will break away from the swamp and move into the soil solutions. Okay, meaning that when you water your vase, okay, you punya pasu with the soil inside and what there is a moisture. Okay, so slowly the soil will it's like will release the cations in the soil solution, meaning that it is still in the vase. Okay, for example, it still swarm around the soil, so that when the plants want to take up the nutrients, it is there, because plant cannot take the nutrients direct at the clay particles. Okay, so it, however, the soil is actually act like a temporary temporary magnet. Okay, it holds for a while. Okay, so when the conditions is suitable, it will make the cations macam hydrate, or saya panggil macam like floating inside the soil lah, so that the plants can take up. But if the soil just hold the nutrients, it cannot release the nutrients to the crops. Okay, so if it's a dry soil, meaning that you did not water your plants, the nutrient is not available for the crops because it is not in a hydrated state. Okay, so adsorbed cation, what is adsorbed cation? It is loosely held on a colloid surface. That is adsorbed cation. This is just the term that you have to understand. However, exchangeable cation is adsorbed cations that can be exchanged with freely other moving cations. That's why we call it as like the exchangeable cation is the most important. How the soil can release or maintain the nutrients inside like one space, so it's available for the plants. It's either lagi satu, the cations are easily prone to leach, meaning that it is not adsorbed cations. Okay, so but it's easily leached down. Okay, so what actually influence this, meaning the ability of the soil to hold or release, that is because of the one of the most important ni adalah degree of the climates. Okay, for examples in Malaysia, Indonesia, we receive a lot of rain throughout the year. It is easily prone to leach, meaning that when you put fertilizer or your soil have nutrients, day by day, if you did not maintain your soil properties, okay, how the cations macam ni, how the cations like the soil, okay, prefer to be held by the soil. If you did not maintain that characterizations, the nutrients will lost. Okay, so later kita akan belajar what actions can we do to maintain the cations or nutrients in soil. Okay, so another one is soil for example, lagi satu, in arid conditions, for examples in Mediterranean areas like Arab Saudi, Jordan, okay, they have no water, they have no rain. Okay, so what will happen? Okay, so there is accumulations of cations, for example sodium, calcium, magnesium, until it is accessed. Okay, the levels are high. Okay, that is because of no rain. That is also another problems. Okay, so another one is because of the soil parent materials. Okay, meaning that the original parents has, for example, it has a lot of calcium. Okay, so it's a calcium rich soil. So that's why it has a lot of calcium, meaning that from the parents batuan tu, okay, the rocks has large amount of calcium. That is naturally lah. Okay, so by weathering, it release the calcium into the soil environment. By weathering, meaning that from rocks it into soil, into a sedimentary soil, sedimentary rock, and that properties is brought together because the parents has more calcium and magnesium, so it will release more calcium and magnesium into that soil. But however, accessibles of over content of calcium and magnesium also is not good for plants. Okay? Because it suppress. Dia it's like, and for example, ants lah. Ants tak ada 6. Dia ada 6 tangan je. It has only 6 hand. But I say, for example, ants, it has six hands kan. So it can hold 6 cations. But all are but the soil just hold the calcium. So what happened to magnesium? What happened to the potassium? Okay, so that's the problems. Okay, because the ability of the soils can hold only 6, for example. But the soil only hold calcium, meaning that there is no space for other nutrients. So it's another problem. Okay. Okay, so this is how it looks like. Okay, so this is clay, as I show you just now, under the SEM image. You can see that it's like flaky. So where does actually the hand or the cation exchange site? It is actually at the surface. Okay, so it's like flaky, so it can be held at the surface lah. Okay, this is how it's look like. So what we call here is, this is, yang if I put it this way, you tak nampak my cursor. Okay, if you see here, okay, can you see my cursor?
Yes.
Okay, so this is a colloid. Okay, this is a negatively charged colloid. Okay, but you can see here it is negative, 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 negative. So these negative colloids can hold positive cations. So a cations that is held at the surface for a moment, for sometimes, we call it as a adsorbed cations. Okay, it is held by the soil temporarily. Okay, then we have what we call as cation in solution. This is the cations or anions in solutions that can be absorbed by the plant. Okay, for example, today, this is example. I want you to understand. Okay, for example, today, the conditions of the soil, meaning that after you water the plants, the soils, this amount of cations are in hydrated state, meaning that this is the cations that can be uptake by the plant at that moment. Okay, however, tomorrow another 2 days, you did not water your plant for 2 days, then the soils are dry. So there is only what we call as adsorbed cation, because it is not in hydrated state. Okay, so there is a difference between cations that you have to maintain in soil solutions, and also an adsorbed cation. Adsorbed cation meaning that you want to sustain the nutrients for a moment, for it to be released slowly lah. Tapi cation solutions is at the moment where the plant can absorb the nutrients, the cations or the anions. Okay, so understand Okay, we have a few types of colloids when we talk about colloids. Okay, so it's actually depends on what we call as a particular compositions. Okay, what does it make from? Okay, the structure, how it is susun, how it is susun apa susun?
Arrange.
Arrange, yes, how it is arranged. Okay, later I will answer that. And the properties, what properties does it bring? So basically, we have 4 types of colloids. Okay, so we have to remember 4 jenis colloid, 4 types of colloid. Okay, we have what we call as crystalline silicate clay. This is the most important. Okay, which we will go into details. Number 2 is we have non-crystalline silicate clay. Number 3 is we have iron and aluminium oxide. From the name itself, we know the colloids should comprise of aluminium oxides and also iron oxides. Okay, the last one is what I mentioned just now, is the organic colloids. So under colloids, we have what we call as clay, and also we have organic colloids, which is the humus lah. Okay, so but the most important is the first one, crystalline silicate clay. Okay, which comprises of tetrahedral and octahedral crystal sheets. So what is actually tetrahedral? Apa maksudnya? What is octahedral? Okay, so we will see the structure. Okay, so that's why I hope you can pay attention in this lecture. Okay, before that, I would like to know, do you have any connection problems? Because I did not record the lecture. If you did not have any connection problems, but if you have connection problems, meaning that you punya tu selalu terkeluar, but selalu saya tak nampak pun ada yang keluar masuk. I believe that your line is okay, but please do tell me if your line is not okay on that day. Okay. Okay, jap. Okay. So ada 4 jenis colloid tadi. We will go to the first one. Okay, so the first one is what we call as a crystalline silicate clay. Okay, but crystalline silicate clay is the most important because it's a dominant type in most soil. Okay, selain daripada soil yang special, actually most of the soils are crystalline silicate clay, comprised of crystalline silicate clay. Okay, so what is a crystalline silicate clay? What does its characteristic? It should have the structure should be like this. It should be consist of oxygen, silicon, and aluminum atoms that is closely packed and tied together. So the structure should be like this. Contoh yang ni bukan jap. Okay, the structure should be like this. It has oxygen, it has silicon, it has aluminium or magnesium, it also has hydroxide. This is what we call as a crystalline structure. Dia macam crystal the structure, susunan, the arrangement of the atom is like there is a what we call as dalam bentuk tetrahedron ataupun octahedron. Okay. Mana tadi? Okay, so all are predominantly negative charged. Okay, mostly it carries negative charge with them. Okay, so this is general one. Nanti we will go into details. So particle shapes, intensity of charges, stickiness, plasticity, swelling behavior is some of the characterization that we will see in crystalline silicate clay. Because as I mentioned, okay, these are some examples of kaolinite and marmorite. Okay, you can see that the structure are different. If in kaolinite, it is it's like 1-to-1, but marmorite is like it has 2 tetrahedral sheet and 1 octahedral sheet. Okay, don't worry, but I'll explain about this later. What is octahedral, tetrahedral? This is just general view of it first. Then if you see about this, you will have sekejap. Okay. So bila kita when we talk about clay ni, that's why I said we want to see the intensity of charges. Which type of soil has good CEC? Which type of clay? Kaolinite ke marmorite? Either which one has more CEC? Which one can hold more water? Which is explaining the stickiness, plasticity, and swelling behavior. Meaning that, for example, kaolinite, it doesn't like water. Meaning that it can't allow water to enter between the layers. but montmorillonite, for example, it allow a little bit of water. Okay, that is what we want to see by its properties lah. Okay, that is because of the structure yang Okay, number 2 is a non-crystalline silicate clay. Okay, so non-crystalline silicate clay is actually they are tightly bonded by aluminium. Okay, you should have aluminium, silicon, and oxygen atoms. But however, it does not exhibit a crystalline sheet. Okay, so if you see a crystalline sheet, it should have a crystalline structure or a structure that is tetap, a structure that is built nicely. However, a non-crystalline is like depends. Okay, it just form a chain, but it doesn't show any state, any shape. Okay, so this is a non-crystalline structure. If you see here, it just like a chain, but it doesn't have any obvious shape. Okay, compared to crystalline tadi kan, as I show you just now, this is crystalline. The atoms are arranged in proper way. Okay, maksudnya dia tetap. Okay. Okay, so a non-crystalline silicate clay, it is tightly bonded by aluminium, silicon, and oxygen atoms, but it does not exhibit crystalline sheets. Okay, there are two types of clay, which we call it as olefin or imogolinite, which is from volcanic ashes. Okay, ashes ni it's a very small particles. Okay, meaning that it comes from a rock. It is a type of soil. It is type of colloids, but the structure of olefin and imogolite are like this. Okay, are like this. Okay, from like this. Okay, so it's a poorly crystalline hydrous aluminium silicate clay mineralite, which it doesn't have any crystalline structure. Okay, so actually it has it carries different properties. Okay, it has high amount of positive and negative charges. Okay, it has low degree of stickiness, meaning that it cannot it doesn't act like a clay. When you hold a clay, you can actually shape it, kan? And you can stick it together by using water, but non-crystalline silicate clay is like ashes. Okay, so cannot. It strongly absorbs phosphate and other anions under acidic conditions. Okay, so this is the properties and characteristics of the non-crystalline silicate clay. Okay, okay, so it's actually the type of soil here is andisols. Okay, which is developed from the organic materials. Okay, if you see here, for examples, in area which you have apa tu panggil? What is gunung berapi? Apa gunung berapi in English? Saya selalu macam lost. Volcano, volcano. Okay. In area where you have a volcano, okay, so it is rich in this type of colloids. Okay. Of course, we doesn't have andisols in our soil because we don't have volcano. Okay, so faham if you have any question you can ask me. Okay, number 3, the third colloids is what we call as iron and aluminium oxide. So this is quite different from clay. Okay, so however it is found in any soil. Okay, kalau you nampak daripada nama dia pun iron and aluminium oxide, meaning that it has to have aluminium and iron. Okay, for examples, this type of soils are in oxysols. Oxysols ni macam tanah dekat Kuantan ni. Okay, it's like the soil in Kuantan which is orange in color. Orange in color reflects that the soil has higher amount of iron and also aluminium because it is oxidized. It characterized by the color. Okay, so this type of soil is found in many soils. Okay, it's a highly weathered soil. Highly weathered meaning that it go through an extensive weathering processes because it has water and oxygen. For example, in our region, we have what we call as warm humid region. Okay, it consists of mainly either iron or aluminum atoms coordinated with oxygen atoms. Okay, so the structure of here is, you see, you have oxygen, you have hydrogen which is attached together, and you have what we call as aluminium. Okay, and this aluminium is attached to the oxygen, that's why we call it as aluminium oxide. Okay, it's bonded by a hydroxyl. So this is hydroxyls. Okay, HO is hydroxyls that gives these colloids the capacity to strongly absorb certain ions. Sebab OH, okay, sebab OH, H tu hujung dia H because the N is H, H is plus. Okay, so that's why it can hold the anions. Okay, so that's why if you see here the for examples, you have what we call as phosphate. Okay, hydroxyphosphate, it can attach to the OH because OH is H is hujung H is plus kan. Okay, so it is attached together. Sekejap. Okay, some such as gibbsite and goethite from a crystalline sheets, other form of amorphous coating on soil particles. Okay, so if you see here, okay, this is the structure of the iron and aluminium oxide. Okay, which it is okay. If you see here, it is only aluminium, but this is example for the aluminium, but iron can also be seated at this place. Okay, but the structure yang ni tak berubah HO, OH ni tak berubah. Only the aluminium here can be substituted by other elements. For example, iron. Iron want to sit here? Yes, can. Okay. That's why you can see here iron. Okay, so OH, this is the OH. Tak nampak arrow tak nampak my cursor. Sorry. Okay, Fe. Okay, so for example, Fe sit here. So this is the OH. Okay, so this is the OH. At the edge, meaning that at the hujung dia, for example here, it can hold the H2PO4 minus. Okay, so that's the reason of why it can hold a lot more anions. Okay, because it has the oxygen atoms. Okay, oxygen atoms which often associated with H ions to make hydroxyl groups. Okay, so it can hold more anion. That is the characterizations of that iron aluminium oxides. Okay, so the last one is the organic or what we call as humus. Okay, so it is not a soil, okay, but it is still categorized under colloids. Okay. So this organic colloids are different because it only dominated by long carbon chain. Okay, it is important in nearly all soils because it helps in retaining the nutrients. Okay, but it cannot but it doesn't have crystalline structure. Dia ada long chain je. Sekejap ada gambar tak? Okay, long carbon chain, meaning it looks like this. It looks like this, but this is not orange, but carbon chain is macam carbon chain lah. The carbon chain are attached together, but it doesn't have a structure like this, no. Okay, so a crystalline structure should have crystal structure. Okay, so what is actually about the first which is the most important, silicate clay structure, crystalline silicate clay structure. Okay, so the most important part is it's like a leaf-like, or we call it as a phyllosilicate structure. Okay, this is the most important silicate clay. It composed of two sheets. We call it as sheets. Okay, we call it as sheet because one is did macam layers. Okay, it form layers. The first one is what we call as a tetrahedral sheet. Okay, so this is tetrahedral sheet. If you see here, it comprised of 3 oxygen. Okay, it is 4-sided. It has 3 oxygen. 4 oxygen, sorry. And also it has 1, 2, 3, 4, 4. Okay, 1 atas and 3 bawah. And it has 1 silicon at the center. Okay, so another sheet that you have to remember is it has what we call as octahedral. Octa 8 kan, octopus. Ada 8 kaki. So it has 8-sided. Okay, 1. It has 4, 1, 2, 3, 4, 5, 6 oxygen and 1 magnesium or aluminium at the center of the structure. Okay, if you see a 3D illustration of it, it's like this. It's like a crystalline structure. Okay, 3D. However, if it's a 2D visualizations, you will see like this. Sekejap like this. Ni 3D juga kan? Okay, the aluminium, this is octahedral. Okay, okay, so this is a tetrahedral. So the layers of the clay, dia akan like sandwich, dia berlapis-lapis-lapis. Okay, so later saya tunjuk dekat you. But the asas dia, the fundamental structure is 2 things. One, we call it as tetrahedral, which comprises of 4 oxygen, 1, 2, 3, 4, 4 oxygen, and silicon at the center. Okay, however, one more is octahedral sheet, meaning that it has berapa oxygen? Berapa oksigen, Alia?
6.
Pandai. Lepas tu kat tengah-tengah dia ada apa, Sarahani? Sarah Muhammad Fatih? Sarah.
Magnesium.
Okay, magnesium, or it can be either tau, bukan magnesium saja, dia boleh jadi magnesium atau aluminium atau ada beberapa lagi yang duduk, nanti saya explain. But the fundamental adalah magnesium. Kenapa saya cakap later saya explain? Because sometimes yang at center ni, silicon ni, okay, the silicon, the magnesium, aluminium can be seated by other element. So itu ada problem, bukan problem, that will cause another things that you will learn. What is that? But the main structure, the fundamental structure is this. Okay, you have to remember. Berapa tadi Mas Rizal? Ada berapa structure? Wan Nasrin, berapa types of sheet?
Um, 2 to 4.
2 to 4? Mana dia? Berapa sheet? How many types of sheet untuk membina what we call as silicate clay structure? Ada 2 jenis kan? One is tetrahedral, one more is
Octahedral.
Octahedral.
okay. So ni kena ingat sampai habis belajar, okay? So sebab because it's a common, it's the structure of a common soil. Okay? So saya ada attach. I attach a few picture of it so that you can imagine or you can illustrate how does it look like. Okay, so please remember the silicon at the center, upper part is the oxygen. It has for tetrahedron ataupun tetrahedral sheet, you will have 4 oxygen. Okay, the structure is like this. You cannot change. Hydroxide. Hydroxide. Another one is octahedron, meaning that you have aluminium or magnesium at the center, and you have 6 atoms of hydrogen, 6 atom of oxygen. Okay, clear Okay, set. Okay, so the fundamental things of this layer is like I said just now, it will be arranged like a sandwich. But what type of sandwich is that? Okay, so you have actually 2 different type of sandwich. Okay, kejap Mana pula benda ni? Oh, okay, yang ni nantilah saya ajar pasal yang tu. Okay, so it will be arranged like this. Fundamentally, dia akan tetrahedral, octahedral, tetrahedrals. Okay, it's like a sandwich. Then it will form a groups of colloids. Okay. Okay, so this is the picture. Okay, so when you already know about the structure of the clay, where does the source of negative charge on clays come from? Okay, if you see here, okay, so if you see here, macam saya cakap, it looks like a hand. Yeah, okay, yang ni clear. It's look like a hand. So, please imagine it's like a layers that has a hand. Okay, so where does the CEC is? Dekat mana CEC tu? Sebab if you see here, dia macam ada satu, it's like it has an empty hand here, for example. Okay, that's some questions that I want you to think. Okay, so where does the CEC sit? Okay, because if you see here, it's like a stable charge. Stable charge meaning its charge, its hands are held by other atoms. Okay, so if you have calcium, where does the calcium sit? Does this calcium want to sit at the H plus or the calcium wants to sit here? Oh, tak nampak cursor. Okay, where does the calcium want to sit? Either at the upper parts of the atoms, H plus, or you want to sit here. Okay, so that is the questions and some things that you have to think. Okay, so however, I will answer that for you. Okay, so the source of negative charge on clays come from two sources or 2 processes. First is what we call as ionizable hydrogen ions. That is what we call as pH dependent charges, meaning that it depends on the pH of that soil. Okay, negative. Faham tak? Maksud saya I repeat this in English, but I speak in Malay first. Okay, untuk ni source of charges ni maksudnya tangan dia soil tu nak sediakan negative charge tu macam mana? Okay, so how does the soil want to form the negative charge which act like a hands that it can hold the cations? Okay, from where the negative charge come from? Because fundamentally the soil doesn't have any negative charge. Okay, it's in what we call as like ambient conditions, no negative charge. So the negative charge is actually developed by some condition. Okay, meaning that the CEC of the soil depends on 2 things. Okay, the CEC value. Okay, the negative value depends on 2 things. One, we call it as a pH dependent charges. Okay, so what is pH dependent charges? Okay, I'll explain a little bit about soil acidity. Okay, so if a soil is acidic, it should contain more hydrogen ions, kan? If a soil is the basic solutions, it contains more hydroxide ions. Okay, so here, when we talk about pH dependence, okay, the negative charges arises due to unsatisfied valence Okay, this is the structure of the clay just now. Okay, if you see here, this is octahedron and this is tetrahedron. Okay, on the upper part, okay, the negative charges arises due to unsatisfied balance. So at the edge, okay, dekat tepi dia tu, okay, ada O negative. Okay, so this O negative will at the broken edges of the silica and alumina sheets. Okay, that's why it hold the H plus. Okay, so at high pH, the hydrogens of this hydroxyl dissociate slightly, meaning that this is at lower pH. At lower pH, you see the H plus is here, the H plus is here, the H plus is here. Why the H plus is here? Is because the O brings negative charges at the edge of the crystal, at the edge of the soil, dekat surface of the soil tadi kan, dekat hujung hujung structure dia. Okay, there is unsatisfied valence. Okay, however, at high pH, the hydrogens of these hydroxyls, okay, OH if it's at high pH, they akan release the H plus. Okay, it will release the H plus into the soil solutions. Okay, that's why it means the words dissociate slightly and the colloidal surface is left with a negative charge carried by the oxygens. Okay, that's why when you put fertilizer, for example, the calcium, okay, the calcium will sit here. But remember, if your soil is acidic conditions, the calcium cannot sit here. Because as I mentioned just now, H plus is very, very selfish. Because when the H plus is in your solution, H plus will sit at the oxygen negative charge supplied by the O negative. Faham tak, Nurin?
Saya tak faham yang kenapa time dia acidic tu, bila dia acidic, H plus tu dia release.
Bukan, terbalik.
Doktor explain balik lah.
Okay. Aniso, let me explain this in Malay first. Okay. So untuk structure ni sama juga untuk octahedral di atas, untuk tetrahedral di bawah. Okay. Dalam keadaan biasa, okay, at the edge ni akan tak terisi. Tapi kenapa? Okay, sekarang ni soalan dia, dari mana negative charge ni datang? Okay, dia ada dua faktor. Satu faktor dia kita panggil as pH dependent yang saya tengah terangkan ni. pH dependent maksudnya dalam keadaan pH yang okay, dia bagi negative conditions. Tapi dalam keadaan acidic pH, maksudnya kalau you tengok kat sini, sebab tu saya explain ni dulu, dalam acidic solution dia mesti ada H plus. Kalau you tengok acidic ataupun pH low, that is because of higher concentrations of H plus. H plus ni dalam acidic conditions, H plus dalam acidic punya air, dalam acidic solution, dia macam terapung-rapung kan. Tapi H plus ni dia bila dia banyak sangat, dia akan bertahta dan duduk dekat O negatif. Dia tak kasih kalsium ke, potasium ke duduk dekat situ. So it's pH dependent. Kalau keadaan tanah you, contoh saya ada kat halaman rumah saya, kerja saya mengasidkan tanah je. Tanah saya tu berasid. Jadi saya tahu yang kalsium saya, soil saya tak ada negative charge. Because of that negative charge diduduki oleh H plus. So the answer is there is no negative charge in an acidic soil. Faham?
Faham?
Okay. Tapi kalau keadaan tanah saya okey, saya jaga dia. Okay, so dalam tanah tu dia punya pH adalah neutral, 7. At that moment, oksigen ni negatif dan H plus ni tak duduk dekat sini. I don't have the picture. Sekejap Tapi H plus ni akan keluar masuk ke dalam salt solution dan kalsium dia akan meninggalkan salt solution tu, dia jatuh ke bawah dan kalsium akan datang duduk dekat sini. That is where the salt is the salt tu ada source of negative charge when the pH are neutral. Faham tak? Ada siapa-siapa tak faham tanya sekarang. Kalau tak faham langsung pun boleh saya ulang lagi. Okay, semua faham Maksudnya bagaimana negative charge ada kat dalam tanah, that is depends on the pH of the soil. Satu. Kalau tanah you tu jenis tak bagus, contoh dekat halaman rumah saya, katalah saya ni kerja nak mengasidkan tanah je, saya pergi tuang asid sulfurik. Contoh So dia ada source of H+. Jadi tanah saya ni pH dia 2. 2. Jadi saya dah tahu dah, at that situation, dalam keadaan tanah dekat rumah saya ni, O negatif tu semua didukung oleh H+. Jadi tak ada source of negative charge. No. There is no at all negative charge. Meaning that if I put calcium, Ca2+, which is the cation, calcium tu tak boleh duduk dekat O negatif ni. Sebab saya dah tahu dah, banyak H+ kat dalam tanah tu kan saya cakap H+ ni saya guna ayat bahasa pasaran, H+ ni jahat. Bila dia duduk kat dalam tanah, dia je nak duduk dalam tanah. That's why it doesn't give any chances of negative charge to be formed at the soil, in the soil. Okay Faham So nanti kalau dalam periksa memang confirm keluar ni. Siapa tak dapat jawab maksudnya dia tak faham. That is pH dependent, meaning the source of negative charge depends on the pH of the soil. Although the soil can provide negative charge, but if the H+ is a lot in the salt environment, the H+ will sit at the edge of the O negative. And it doesn't allow any cation to be seated at the edge ataupun because it doesn't have any negative charges. The negative charges is satisfied by the H+. H+ dah duduk. H+ sit at there. Okay? Okay, Anissa, I repeat in English. Okay, so there is two types of negative charge, meaning for example, a soil is having 43 negative charge. Okay, so 43 amount of negative charge ni, okay, this 43, okay, how many negative 3, meaning macam mana nak cakap? This 43 amount, okay, for example you have 43, then you have 22, then you have 20 charge. Okay, what conditions determine this value? 20 negative charge, 22 negative charge, 43 negative charge. It is determined by two factors, which the first one I explained just now is the contents of the H+, meaning that the pH of the soil. If the pH of the soil is acidic conditions, okay, so here I wrote here acid, okay, so the pH is 2, okay, so it has a lot of H+. Okay, when it has a lot of H+ in the soil solution, okay, for example like this. Okay, for example like this, H+, you can see H+ here, you can see H+ here, H+ here, but this is in neutral. That's why you can see K, Mg, Al. Okay, but if all the nutrients, the anions and cations in the soil solution is H+, meaning that only H+ satisfied the negative charges radiated by the O negative, meaning that there is no negative charges. That is because the soil is acidic conditions. In a simple way, I would say that acidic soil doesn't provide negative charges to the soil, meaning that the soil cannot hold cations because the negative charges radiated by the O negative is seated by the H plus. So calcium nak duduk kat mana? Where does calcium want to sit? No space. Meaning that no negative charges supplied by the soil. Understand, Aniso?
Yes, doctor.
Huh?
Not completely, doctor.
What? What, Aniso? Just now you said.
Yeah, I tell you, like, I didn't understand completely.
I see. Maybe you have to read. Okay. So however, it depends on the pH. If the pH is acidic, the H plus is more. H plus will sit at the negative charged. Okay, as I mentioned before, it's like a magnet. Okay. So any questions other than that? I mean, do you understand for the others? Okay, I assume you understand. Okay. Okay, number 2. Maksudnya, how you want to make the soil ready with negative charges is depends on what we call as isomorphous substitution. Okay, so what is isomorphous substitution? Okay, so isomorphous substitution is the substitution of one element for another in a mineral without a significant change in the crystal structure. Okay, tadi saya cakap kan, I mentioned just now, at the center you have magnesium and aluminium. Okay, but this can be changed by other element without changing the crystal structure of the soil. Okay, so the elements can be substituted for each other, usually that have a similar ionic radius and valence state. For example, if tadi ni dah cakap kan, dekat tengah-tengah dia aluminium, but in isomorphous substitution, silicon can sit at the aluminium tempat aluminium. What is that? Tempat aluminium position. Okay, so meaning that the silicon will substitute. Okay, sekejap terbalik. Okay, the silicon will substitute. Okay, sekejap terbalik. This aluminium can substitute the silicon space. Okay, this show that the aluminium is slightly higher, larger than silicon because it has 0.05 nanometer radius of aluminium. So this aluminium can fit into the center of tetrahedron, okay, in the place of silicon, meaning that the aluminium place the silicon. If you see the structure just now, if it's tetrahedral, silicon is at the center, correct? Okay, but how you want to, how the soil want to make the soil have negative charges? By isomorphous substitution, meaning that aluminium will sit at the silicon space atau silicon position just now at the center. That is what we call as substitute. Dia gantikan tempat tu. Okay, so this process is one elements fill a position usually filled by another of the similar size. Okay, for example, aluminium and silicon, which the radius are almost the same. Okay, then in octahedral sheet, the magnesium can substitute for aluminium and the aluminium can substitute for the silicon. Okay, meaning the smaller one can substitute the larger one. Okay, so isomorphous substitution is primarily source of both. This is the primary source. Okay, for example, just now when I say about pH dependence, it's depend on the pH, meaning that it's due to your practices. Okay, but in most of the soil, the primary source of the negative charges is because of the substitution, what we call as isomorphous substitution. Okay, so for example here, Mg can replace the Al3 plus. Okay, so how it is formed. Okay, for examples in trioctahedral sheet, okay, means that you have 3 magnesiums of atom. If you see here, okay, the atoms are at the center, which is 2 plus 2 plus 2 plus. Then it is substituted by the 2 aluminum atoms, meaning that 2 aluminum atoms sit at the center. Okay, so if the aluminum is replacing the magnesium, okay, so it will give another negative 1 charge. Okay, if you see here, this is 3, 3, 6 positive. Okay, if you see here 2 negative, 2 negative, 2 negative is because of the oxygen. Okay, O2 negative. Okay, if you see here 2 negative is the oxygen. Okay, so it have 3 and this is 3 negative, and here you have 6 negative. Okay, so in total it doesn't have any negative charge given, but if it is substituted by the what we call as, one is aluminum, one is the isomorphous substitute by the magnesium here, then it doesn't satisfy 1 sebab dia jadi 3 tambah 3 plus plus 2 plus is 5 plus. Okay, sorry, just now 2 negative, this is oxygen, but oxygen is O negative, it carries 1 charge only, O negative. That's why it is 3 negative here, because O negative, O negative, O negative. Okay, so here is also O negative, O negative, O negative, so it brings 3 negative charges. So here is that 6 negative charges and 5 positive charges. So it doesn't satisfy another negative 1 charges. So negative charges is here. So kita nampak kat sini O ada satu lagi negatif, ada satu. It's like O can help another 1 cation. Okay? Faham Senang, simple je. The idea is that when the magnesium substitute the aluminium position, it doesn't, dia macam, it's like dia ada 3 tangan, contoh it has 3 hands, but 1 more hand where? So that's why it is dia menyediakan satu negative charge untuk soil tu. That is how the soil form a negative charge. The cations exchange capacity site. Okay, so this is another this is the same examples. Okay, for example here is, you see here O negative, O negative, O negative, so we have 3 negative. Okay, so here we have O negative, O negative, O negative. Okay, this okay, so here is 3 positive, here is 2 positive, 2 positive. Oh, tak nampak cursor sekejap 2 negative, 2 positive here. Okay, so 2 positive, we did not satisfy 1 of the negative charges, so the net is negative 1. So this is how the negative charges is provided by the soil colloids or soil. Okay, so the same when we talk about which one can substitute is yang ada similar ionic radii. Okay, so if you see here, yang similar adalah silicon, aluminium and ferrum is around 42, 51, 64, and another, this is also zinc can substitute the magnesium space, the magnesium position. Okay, so this is how it is exchanged, dia macam gantikan tempat. Okay, it substitute the place of the aluminium or ferrums or silicon. Okay, so these are some metals that having a similar ionic radius. Okay. Okay, settle how the cation exchange site or the negative charges are radiated by the soil. So we go to how the acid cation replaces non-acid cations. If you see here, That is what we call, this is in soil. You can see that some of the soil, what we call as exchangeable cations. Okay, so the soils are negative. So it hold the positive cations. Here you can see that, here you can see that the soil hold the aluminium, the soil also hold the calcium, the H+. Okay, so this is what I call just now the H+ jahat In acidic condition soils, the H+ will sit at all the negative charges radiated by the soil. That is because of the H+ has the highest, the smallest radius, okay, and the highest affinity to be absorbed by the soil. So, bila H+ tu banyak, macam saya cakap tadi, pH kat rumah saya, tanah dia 2, the H+ are a lot, the H+ will sit at all the negative charges in the soils, and it will leach down the calcium and all the magnesiums and all the cations downward, meaning that it will be lost from the soil environment. Okay. Okay. So that is how it works in the soils, how the negative charge are formed and how the cations are maintained. That is because of the pH dependence, satu, and who substitute who, and which cations dominate the soil. For example, H+ has the capacity to dominate the soil very well, so dia akan throw away the calcium. It can leach away the calcium because it want to sit at the negative charges just now. As I mentioned, please remember H+ will sit. If the H+ is in a lot, in a lot amount, in larger amount, so dia akan duduk kat tempat negative charges. Okay, then we have okay, now we go to another sections, okay, which is the mineralogical organizations of silicate clay. Okay, as I mentioned just now, we have a few types of clay. That is why we this type of clay is named based on the susunan, the arrangement of the clay. Two types of sheet, we call it as tetrahedral sheets and octahedral sheets. Okay, so basically, generally in soil we have a few two types of clay. One we call it as 1-to-1 silicate clay. Another one is we call it as 2-to-1 silicate clay. Okay, so there is a difference between 1:1 silicate clay, 1-to-1 silicate clay, and 2-to-1 silicate clay. That is because of the arrangement. Okay, so if it's 1-to-1 silicate clay, the example of the clay is what we name as kaolinite. Okay, 2-to-1 silicate clay is smectite, vermiculite, illite, and marmorillite. We will go into details. Okay, so what is 1-to-1 silicate clay? Sekejap So 1-to-1 silicate clay, just now I mentioned the name is usually kaolinite. This type of clay, it has, the layers are like one tetrahedral at the upper part and one octahedral at the lower part. Okay, so tetrahedral, octahedrals, then they continue balik dengan tetrahedral, meaning that satu stack tu ada one tetra, one octa. Okay, sekejap saya skip. Another one is we have what we call as 2-to-1 silicate clay. So 2-to-1 silicate clay, we will have the upper part which is the tetrahedral, continued by the second layers. Ni macam sandwich. Dia macam the upper part is the bread, the lower part is the bread, the center part is the fill kan, the tuna contoh. Okay, so the center part is the octahedral. So the susunan are different. Tetra, octa, tetra, tetraback, octaback, tetra. So layers is like this. Okay, tetra. Kejap tunjuk Okay, so tetra here, octa here, tetra. So the second layer is tetra octahedra in comparison to 1-to-1. If you see 1-to-1 is like this. Tetra, octa, tetra, octa. Okay? Faham tak? Siti Nur Farahin, faham? Okay. So dua jenis clay, two types of clay. First is 1-to-1. Memang the name is 1-to-1 type of clay, 2-to-1 type of clay. So 1-to-1 is usually kaolinite. The kaolinite ni is the name of the clay that is characterized by the layer which has one tetrahedral sheets and one octahedral sheets. Okay, so it is stacked together. Okay, dia tu, and between, the most important is that between the layers here, okay, if you see tetra, octa, so di antara between the octa and tetra, because the ni is O negative, here is O, here is O. So it is bound by what we call as a hydrogen bonding. Okay, so this hydrogen bonding, you see here, this is the 3D structure of the what Allah, the sheet. Okay, so if you see here, okay, this is OH. Okay, this is OH. Okay, which come from the octahedrals. Okay, OH from the octahedrals, hydroxide. Okay, the upper part is O. Okay, ni O. So between here and here, this is what we call as hydrogen bonding. Okay, so this hydrogen bonding, as you learned before, it is a ikatan yang kuat, a tight bond. So when it has a tight bonding between hydroxyl ions and oxygen ions, it prevent the expansion between layers. Okay, meaning that when there's a tight bonding, the water cannot go through between the layers, and not only that, there is no cation exchange capacity, meaning that the nutrients cannot be exchanged in this type of clay. Please remember that this is the characteristic of the kaolinite. That's why kalau you nampak, if you see there are clays that you can do what we call as labu sayung air itu kan. It is made from clay, the container of the water. Wait, I show you. Apa labu sayung Okay, so this is the container, water container. Aniso, have you seen this?
Yes, doctor.
Okay, so this is what we call as clay that did not allow water to infiltrate between them or be within the sheets of the clay. That is because the structure is packed together tightly. So this type of clay is 1-to-1 type of clay. Okay, consists of kaolinite, which it doesn't expand. It doesn't expand when there is water. However, there is certain types of clay that expand when there is water. Okay, contohnya air, maksudnya in English in BM, air tu dia bila dia kena dekat jenis clay tu pegang air tu banyak. Maksudnya tanah tu jenis mengembang. The soil will expand when there is raining. But this is not one-to-one. No, it doesn't allow water to get through the layers. No, that is because of the hydrogen bond between the hydroxyl hydroxyl and also the oxygen. Okay, if you study, you please illustrate or try to understand the structure, because this is OH, this is O. So you have to identify the bonding is here, because usually I will ask in the exam questions, where is the hydrogen bonding? Okay. Okay. So this is that's why I attach a lot of pictures for you to study and have a look, but please do not depend only on my lecture or study notes. Okay, you also have to refer to the books, okay, or journal. Okay, so here is the hydrogen bonding. Okay, here, somewhere here, because it's between OH and the O. Ni the tetrahedral. So that ties together is here. This is the O and H. This is the bonding here. Okay. Okay. Okay, this is the same thing that I put a few so that you can have a look on a few of several picture. Okay, so one types of clay, it is stable, it doesn't expand, it has low total charges, it has relatively low specific surface area. Okay, it has pH dependent charges. It doesn't, meaning that it doesn't depends on substitution. Apa dia? Apa tadi substitution? Isomorphous substitution. Yes. Sebab dia ada hydrogen bonding. It doesn't allow any changes. Okay. So this type of clay only depends on the first factor, pH dependent charges, that can give negative. Dia ada, it has negative cations but very small. That's why low total charges, low specific area. It depends on pH. Okay, however, it has good physical properties because it doesn't expand when there is water. Okay, so it limit holding capacity of nutrients because it doesn't allow another like silicon to replace aluminium. No, it doesn't allow. Okay, so these types of clay, it's good for roads, buildings, ceramic, bricks. Okay, that is the usage of this type of clay. Okay, so we go to the second one. Second one is we call it as 2-to-1 type of clay, 2:1. It is expanding, but it expand pun ada 3 jenis, 3-4 jenis. It has 3 to 4 types of clay. Okay, it can shrink and swelling based on the clay and its characteristic. However, it is not like 1-to-1. 1-to-1 ni dia macam very macam tu dia, macam kotak kan, dia tak, it doesn't allow any changes happen to the structure. But 2-to-1 is quite flexible. However, ada beberapa jenis juga. Okay, so good soils for crop is managed properly, not affected much by pH, meaning that the charges are from the isomorphous substitution process. Okay, ingat, charges in soils are by 2 factors, pH dependence or isomorphous substitutions. Okay, so 2-to-1 types of clay is mostly depends on the isomorphous substitution. Okay, so 2-to-1 silicate clay, this is the 3D picture of it. You can have a look. It's like a sandwich. Okay, so the upper part should be consist of the tetrahedral. Sekejap saya nak tunjuk ke Zah. Okay, so this is the upper part. Okay, it is tetrahedral. Then the center part should be octahedral. Then the lower part is the tetrahedral back. So another layer followed by the tetra octahedra. Tetra octatetra. Okay, clear? Okay, so what makes this different from the 1-to-1? That is because of, kalau you tengok tadi, if you see here, the octahedral layers will meet the tetrahedrals. But in this case, okay, in this case, 2-to-1 types of clay, here is the tetra, meaning that the edge of it is O negative and the edge of this is tetra. Okay, maksudnya the layers, this is one layer, this is the second layer. Okay, so oxygen will meet oxygen. Just now is different. Just now is hydroxyl OH meets O. That's why it has hydrogen bonding. Sekejap, eh. But here, the case is that the oxygen meets the oxygen. So oxygen and oxygen, dia panggil what bond is that? It's a loosely bound by a weak oxygen to oxygen and cation to oxygen linkage. This is what we call as a oxygen bonding, or we call it as, ada satu lagi nama, lupa lah. Van der Waals is it? Sekejap apa nama ikatan dia? This is hydrogen bonding. We call it, but usually I'll use the oxygen bonding lah. So oxygen bonding is different. If you see here, because at the edge kan, actually the picture is the same. Which one you prefer je, sebab tu saya tampal, saya paste banyak-banyak so that sometimes you can see from here kan. Okay, by in details you can see here. If you see here, this is oxygen. Okay, this is oxygen. So when oxygen O at the edge and O at the edge, it is no attritions. It likes, it has O negative and O negative. However, it's stuck together. It is still connected together by a weak bond. A weak bonding. Okay, different daripada dengan colloid tadi. Colloid is hydrogen bonding. Okay, so when it has yang ni lepas you faham yang tadi baru you boleh tengok yang ni. So O and O, it has a weak bonding. So between the layers, it allow changes of hydrated exchangeable cations. Meaning that kalau you if you have cations in the salt solution, solid solution and salt is different. Salt solution is like the medium everything yang macam cation yang floating. Okay, tapi salt is that salt that has the ability to hold the cations. So that is here. So the exchangeable cations can be seated at 2-to-1 type of clay because of the weak bonding between tetra and tetra. Clear? Okay, so ni pun sama jugalah kalau you nampak. This is the interlayer. Okay, this is the oxygen layer, this is the oxygen represented by the red color. So the cations can swarm between the soil can help the cation here between the layers. Okay, so in this type of soil, it has higher CEC, but it also depends. Okay, depends on mormorillite ke, illite ke, okay, depends on the name of the clay. Okay, properties of the clay. So this is the theory, the fundamental is because of the structure. Okay, so we go for the first one. Okay, so smectite groups is interlayer expansions may occur as H2O fills space between layers in dry clay. Number 2 is the mormorillonite is a very common smectite, meaning that under the smectite 2-1 groups, we have what we call as type, the name of the clay is mormorillonite. Okay, so it has a large amount of negative charges due to isomorphous substitution. Okay, so magnesium often replace aluminium in octahedral sheet. Okay, it comes together. Okay, meaning that this isomorphous substitutions happen in octa and also tetra at the same time. That's why soil may have more than one unsatisfied charges. Okay, so aluminium replace silicon in the tetrahedral sheets. Okay, so another reason is why it allows expansions and water holding capacity by the salts and cation exchange capacity by the salts. That is because of the weak oxygen linkage, weak oxygen bonding between the layers. Okay, so this is mormorylite. Okay, so this is the structure of mormorylite just now. If you see kaolinite structure, they're different kan. Okay, then we have what we call as vermiculite. This is another types of 2-to-1 of clay. Okay, so vermiculite is little expanding. Tadi yang tadi dia banyak tau expand dia. Yang vermiculite is little and some swelling, meaning that it allows only a little bit of water. Okay, that is because of the octahedrals dominated by aluminiums, but the tetrahedral sheets considerably frequent substitutions of aluminium in the silicon position, giving rise of the CEC. This vermiculite is the best type of clay. We have a few types of clay just now as I mentioned kan, tapi a comparison between kaolinite is out lah. It cannot allows nutrient ataupun cation exchange, but this smectite little bit, and vermiculite is the best. It has bigger CEC, okay, because it allows more isomorphic substitutions. Okay, so this is ni. Okay, so sekejap yang ni comparison dia. Okay, tadi vermiculite. Okay, smectite dia allow banyak. Vermiculite allow water molecules at intermediate, and it allows magnesium and other cations. But another one, we have what we call as mica ataupun the mica groups is a non-expanding pula. Okay, so you have to remember these 4 types. Okay, mica groups is elite and glaucolinite. Okay, in this case, aluminium substitute for 20% of the silicon in the tetrahedral sheets. Okay, so but in mica groups, bila dia allow substitutions, only K nak duduk dekat situ. The K charge, K positive. Okay, so this is the properties of mica groups clay. 2-to-1 mica, it only allow K plus to 6 sit at the center, between the layers. Okay, so if you see here, okay, mica groups, K is at the center here. Okay, only K is allowed to be seated there. The last one, this is elite. Okay, sama juga macam tadi lah. This is the same thing. Okay, so this type of soil, it has this results in higher net negative charge in the tetrahedral sheets and attract only K ions that fit in the hexagonal holes. Only K can sit here. Okay, this is much the same thing as with vermiculite. Okay, sama juga macam vermiculite, it allow changes tapi it allows K are tightly bond. Tapi so bila K are tightly bond, automatically it doesn't allow exchangeable cations to any exchangeable cations. Very limited lah. Okay, so ni pun gambar yang sama. I just want you to understand, that's why ada a few pictures. Please don't get confused which one you prefer for you to understand. Okay, so this is the K layers here. Okay, so it's a fairly nutrient poor. Okay, sebab dia only allow K. Okay, so another one, we have what we call as the last one. We have, this is the comparison between 3 tadi. This is the chloride. Okay, so chloride, it is non-expanding. Okay, because it has a hydroxide sheet pula kat tengah dia. Okay, so chlorides are also non-expansive. It is almost the same as 1-to-1 kaolinite. Okay, where the H bonded to atoms between sheets. Okay, so OH yang duduk dekat sini, so dia macam ada a tight bonding between a hydrogen bonded between the oxygen atoms. Okay, so chloride are also a not good type of clay. So between these 4, you can see the comparisons of different types of clay. Okay, so each of the clay, this is 1-to-1 and this all is 2-to-1. Yang saya nak highlight 1-to-1, it's not expand, it is hold by a hydrogen bonding. This one, the yang ni. However, 2 to 1, you have 4 types. You have smectite, you have vermiculite, you have mica, and you have chloride. Each of the clay has different characteristic, but vermiculite is the best one. It's the most significant in agriculture. Can be utilized lah, this type of soil, because it can allow nutrient changes and it allows some swelling, meaning that a moderate water can comes in. This one is not so good because dia swelling. Bila hari hujan dia, when it's raining, it tends to absorb the water and the soil will become swell. Okay, so ni samalah for you to clearly, you can study using this. The few. Okay. Then we have, okay, ion exchange. Okay, so when we talk about ion exchange just now, the substitution process of one ion for another on the surface or the interstitial spaces of a crystals. So cation exchange is exchange of the cations. Okay, this is more on term that you have to use later. Okay, kita ada cation exchange, then we have an ion exchange. So what is so great about the ion exchange? What is the importance? Okay, so it is important for the soil too. Firstly, it's important for the soils because soil can constantly supply nutrients for the plants, meaning it can hold, it can release, it can hold, it can release. It's not that it can hold that it cannot release. No, that's why a soil has the ability to exchange cations. And also it can retard and release the pollutants into the groundwater. Meaning that macam sebelum ni saya cakap, soil is it's like a filter. It helps to hold for a while all the pollutants, which we also can do at the moment. We can do what we call as soil remediations before it enter the soil water environment. Okay, soil act as a filter because we have to conserve the water environment because it's our source of food, it's our source of drink, kan? Okay, so these are some definitions that you have to remember. Cation, what is a cation? Cation is ion which that carries positive charge. For example, calcium, magnesium. Cation exchange is a process of the cations, the changings of the cations. Cation exchange capacity is different from cation exchange. The cation exchange capacity is the ability kebolehan tanah tu, ability of the soil to hold for a while the cations. Okay, so please do not get confused. What is cations? What is cation exchange and what is cation exchange capacity? So setiap tanah, each of soil has different cation exchange capacity. Okay, for example, CEC in sandy soils are different with CEC at our soil in our garden, different. Okay, so why it is different? Okay, so what controls on ion exchange? Okay, apa yang control dia? Macam saya cakap tadi, why hydrogen ni, kalau if the hydrogen is a lot in the soil solution or in the soil environment dalam bentuk hydrated hydrogen, why, kenapa dia jahat tadi saya cakap kan? Okay, why? Okay, because the strength of the adsorptions. Okay, you have what we call as, it is related to hydrated ionic radius and valence. The smaller, okay, the smaller the radius, okay, here see here two picture here, the upper part and the lower one. Okay, the smaller the radius, the greater the valence, the more closely and strongly the ion is absorbed. Okay, so hydrogen is actually, it has a very small radius and smaller valence. Okay, so it easily attached. Dia daya tarikan dia lebih kuat, kan? Bila kita belajar, dia bila makin besar dia punya radius, okay, dia makin loosely held, kan, by the chemicals punya bonding. Okay, so it's in relative concentration in soil solution. It should have a ratio law calcium to magnesium, for examples, because calcium are held tightly more than magnesium. If you put a lot of calcium, calcium akan berjaya duduk kat situ. Magnesium second one. But if there is a H plus will sit at all of the cation site and did not allow calcium magnesium. Why? Because the answer is because the smaller the radius and it has a greater valence. Okay, so that it is closely and strongly absorbed by the soil. Okay, faham eh? Okay, so kejap saya lompat ni kejap. Okay, so susunan dia is like this. Kejap mana? The arrangement is like this. Okay. Okay, here is actually you have H plus. Okay, of all the nutrients, this is the of all the nutrients, this is the what we call, this is the arrangements of the cation selection. If H plus banyak, H plus akan ada tendency, H plus will be absorbed tight by the soil compared to Ca. So this is the selections of the cation. Okay, H plus followed by aluminium, strontium, calcium, magnesium, K is equal to ammonia and also Na. Okay, meaning that if you, sebab tu saya cakap tadi, the H plus is jahat, that is because the H plus has higher affinity to be held by the soil. That's answer why the H plus just now. Okay. Okay. Ada soalan tak? Ada yang tak faham? I think dengar je lecture saya, insyaAllah you akan faham when you read. Because it needs reading in this for you to understand. They need to understand. Okay, that's why I ask you to pay attention, because while you read or study nanti you akan faham. Okay, so another one is that there is the selections of the cations. The principle governing cation exchange reactions. Okay, meaning that in soil, what happened with the cation exchange reactions? Okay, first, it has to be reversibility. Yang ni kena hafal ada 5. Reversibility meaning that if the soil colloid hold the sodium and in the soil solution there is H plus, okay, H plus, it can be exchanged. It is reversible. The H plus can sit and dia akan release sodium. But if the sodium want to sit there, the sodium can replace the H plus. But the exchangeable is depends on few factors which we will learn later juga. In these 5 factors. Okay, please remember it can be exchanged. Number 2, it has to be charge equivalent. Meaning, if the soil have 2 hands, okay, for example here, it holds 2 calcium, Ca2 plus. One hand can only hold 1 charge, meaning that if calcium have 2 charge, 2 plus here, 2 plus, okay, it can hold Ca plus here, Ca plus here, 2. If it wants to exchange, dia nak tukar, the soil can hold 2H because 1H carry 1 charge. Okay, and if it's reversible, 2H plus will release back into the soil solutions and Ca2 plus will be absorbed at the soil colloid. It depends on the charge. That's why it called as charge equivalent. How many charge? If for examples Al3 plus sit here. So if Al3 plus is released, berapa H plus akan diabsorb, Mas Rizal?
2.
Al3 plus.
3.
3. Okay, faham kan? Okay, kalau
Faham.
Mg2 plus sit at the soil colloids. Berapa H plus akan duduk, Nadia Amira?
2.
Pandai. Okay. Very good. Okay, so that's why you call it as charge equivalent. Okay, so you have to remember lah kalau calcium is Ca2 plus, Mg2 plus. Kalau Ca2 plus nak replace dengan Mg2 plus, berapa?
1.
Pandai. Okay, macam tu Jadi berapa, macam dia satu tangan boleh pegang Mg2 plus. Jadi dia akan tarik lagi contoh Mg2 plus tu dia buang, dia akan tarik Ca2 plus 1 juga. Okay. Okay, that is charge equivalent. Okay, number 2. It depends on the ratio. Ni paling penting. Ratio law. Okay, so kalau in the soil solution, okay, for example, if your soil colloids can hold 20 calcium and 5 magnesium. Ini dalam soil solution dalam soil solution. Jadi kalau you nampak dekat sini, the concentrations of the amount of calcium is 20, the amount of magnesium is 5. So it can absorb by range. Okay, for examples, it can absorb 16 calciums and also 4 magnesium. That's why in soil solution, it has to be balanced. For example, if you put too much of calcium will sit at the soil colloid and it will suppress the availability of magnesium. Okay, faham? Okay, maksudnya macam ni. Another thing is that kalau dalam soil you ada H+, H+ akan duduk. That is because the values of the H+ are small and by ratio law. Ratio law kata H+ banyak dia duduk. H+ lah duduk. Now the calcium banyak. Calcium yang dapat duduk dalam. Ni ada 20 tangan kan. Soil ni boleh pegang 20. So the 16 come from the calciums. The 4 comes from the Mg. Sebab dia ada 20 tangan je. It has only 20 hands to hold 16 and 4. Okay, that's why you have to be balanced. Kalau by right, sebenarnya 16 and 4 ni the concentration is not stable tau dekat dalam soil, because it's like calcium to magnesium it has to be 1-to-1. Maksudnya if you have 16 calcium, you have to have 16 magnesium. Or if you have 4 calcium, you have to have 4 magnesium, 1-to-1 ratio. Okay, so it's not balanced here. But what I want to say here, that's why you cannot put extra fertilizer calcium contoh, because it will suppress the availability of nutrient. Why? Because the calcium at the CEC site are seated by the calcium, most of the CEC site, because of the ratio law. Because calcium dia berjaya duduk kat situ sebab dia punya sifat kimia, because of the chemical properties. Faham tak, Mas Rizal?
Kurang.
Kecewa. Okay. Kalau, okay, dia mana ada 2. Okay, saya explain in BM dulu ni. So, dia macam ni. Dia macam baldi. You sediakan 2 baldi. Satu baldi tu penuh, you dah bancuh kalsium. Okay, satu lagi baldi tu separuh je, you bancuh magnesium. You pun tuang kat dalam pasu. Pasu ni besar lah sebab dia pakai baldi kan. Satu pasu ni. Okay. So, banyak sangat kalsium. Kurang magnesium yang you bancuh kan. Bila you tuang dia, kalsium tu akan naturally dia duduk dekat site CEC tu. Jadi, kalau CEC tu ada 4 tangan saja, 3 kalsium duduk. 1 magnesium duduk. Tak stable. Faham tak, Mas Rizal? Maksud saya, dia bergantung kepada kepekatan. Siapa lagi pekat dia dapat duduk. Tapi bergantung kepada kepekatan pun, dia bergantung juga pada affinity, apa ni tadi? Kita punya hydrated ionic radius tadi, macam saya cakap tadi kan. Kalsium ni dia kuat untuk duduk. Dan you bancuh pula dia dalam keadaan yang pekat. So dia berjaya duduk. Dia nak duduk situ. Jadi bila dia dah duduk kat tempat CEC tu, CEC ni ada 4 tangan je. 3 kalsium dah duduk, 1 je untuk magnesium. Lepas tu you tuang lagi potasium. Potasium dah tak ada tempat dah sebab dia ada 4 tangan je. Soil CEC is thick tau. The value of CEC is, it's not like permanent lah. Tapi at that moment, if it has only 20 CEC, 20 hands, it can only to hold 20 cation. Okay, faham tak Nurin? Yang lain tu saya tak ingat nama, sorry.
Tak jelas sangat lah doktor. Sebab macam dalam contoh yang doktor kasih tu, kenapa dia jadi 16:4?
Okay, that is because of the concentration. Dia itu contoh je, tak semestinya 14:4. Dia nak tulis 15:5 pun boleh juga. Faham tak? Meaning that to say the soil is the concentration, the soil hold the cations depends on the concentrations. Faham tak?
So kalsium tu duduk situ sebab dia lagi banyak.
Yes, sebab dia lagi banyak. Dan extra kalsium tu ada kat dalam soil solution sebab tu sini dia jadi 4 dekat sini. Tapi this value is not stick like this. It doesn't have to be 16, 4, 1, 4. Tak. What I want to say here is that you can see that the calcium here is more because of in the soil solution the calcium is more. Yang ni dia dah duduk kat CEC dia dah rapat kan? It is attached to the soil colloid kan? Faham tak Nurin? Semualah. Please kalau tak faham bagi tahu saya. The idea here is not the value, bukan 20, bukan 5. The idea here is that if you see here calcium is more, 20. That's why it is absorbed here 16. It can absorb here 14. Kat bawah ni 5 boleh. Tapi what I want to say here is the ratio. Okay, the ratio if you put 20 to 5, calcium 4 kali ganda, 4 times higher concentration than magnesium, kan? So kat sini dia it has 4 times higher it can be absorbed by the soil colloid. Faham tak Nurin?
Faham. Kalau kalau macam contoh tu doktor kasih 20 kalsium, yang 20 kalsium tu attached to the colloid. Tapi kalau
Bukan. 20 kalsium ni is not attached to the colloid. 20 kalsium ni yang saya tengah gerakkan ni, it is in the soil solution.
Kalau macam tu, kalau magnesium tu yang lagi banyak, adakah
sama juga. Magnesium tu akan sit at the soil colloid. Dia jadi 16 magnesium kat atas, 4 kalsium kat bawah.
Jadi tak tengok affinity ke?
Tak. Dia depends. Dia depends on the soil. That's why these 5 factors have to be it comes together. Okay, so it's changing. Dia prinsip dia macam tu. Okay. If the magnesium is high here, magnesium will sit more lah because by ratio law dia concentration dia lagi tinggi. Okay, tapi if it's 1-to-1, Nurin, if it's 1-to-1 meaning that you put 5 calcium, you put 5 magnesium, who will sit? Who will have the higher chances to sit at the CEC side, Nurin?
Kalsium.
Yes, correct. Macam tu lah.
Oh, so sini memang tengok ratio je?
Sini tengok ratio lah.
Alright, faham.
Faham. The usual question is not macam to details yang macam saya akan gabungkan dua prinsip tu lah. But I want you to understand. Meaning that if it's in the field, when you put calcium more, calcium will be seated at the cation site. But if it's in the field, kalau dekat ladang, if it's in the plantation, you put more magnesium. Magnesium will be expected to attach at the soil colloid. Faham tak? Clear? But the amount jangan pay attention to the amount. 25, 16, 4 ni no. Nothing on this. I think this is about ratio. If you have like 30 and 10, so the 30 calcium kat sini might be 15 calcium and 5. It depends on the soil. Kita tak boleh